Okay, we are getting to the heart of the course now. We're going to be doing the task analysis, the actual task analysis that you'll use for a pretest. And indeed, the task analysis will be the focus of your instruction. It'll guide the instruction. So we are down in the green section here. And a couple of notes. The task here has been changed. Before I had something about progress monitoring, and then it occurred to me that that would be in the next course. And then same with this other task where I had originally was going to ask you to look at a website with RTI on it, and that's going to be for the next course. If we can provide that course, that would be in there. So instead, I have an article about actually a task analysis where they actually break down the ideas behind doing a task analysis. And then you'll actually create a task analysis and you'll submit it. And let me caution you, this is sneaky tricky. People really have to, it's a skill that you develop to take this concept and break it into little pieces, break the steps, identify all the steps. This is really challenging, and it's really a change in a mindset about how we look at math topics. So be prepared for some feedback on that, in which you'll need to revise. I would say the majority of the people end up having to revise. And that's what we're designed to do here, is we're designed to give you that interaction so that you can get better. So again, I have on here, omit the progress monitoring, and then here's the reading part of it. The article that I give you gets into some heavier terminology and ideas. What I'd like you to do is just focus on the steps. Don't worry about learning the terminology and digging too deep in this. I really want you to just get the general idea of what we mean and how this kind of undergirds the task analysis that we'll be working on. And this is the cover of the article. I have this posted for you. So that you could look at it if you want to see it in its entirety. But what I've done is I've taken excerpts from the article, and then I have a Word document where you would enter your responses to some questions I pose, so I can kind of guide you through reading this document. And also wanted to narrow the focus so that you're only working on the task analysis part. And I'll ask you some questions where you'll be asked to make an educated guess. So you might be like, I don't see the answer in here. You have to kind of think of some answers, and then I provide my responses so that you can compare and get from this what I'm hoping you get from it. And you're always welcome to ask if you want to email me or even talk on the phone if you need additional information. So again, you're going to omit the progress monitoring aspects of it. And so what we're focusing on now is the actual steps the student is to take. We've created the objective. We've talked about shaping and how we use that to move a student through a process or to engage in a desired behavior. And now we're going to actually look at the steps, the mathy steps that are involved. So the objective is for you to take a math objective and to break it into a list of steps. And we have a formal process for doing that. For those of you that are in special ed, and if you may have done the task analysis for like a student getting dressed or doing some sort of behavior, greeting people. And so that's what we're brushing your teeth. And that's what we're going to do here with the math. So this presentation will consist of two parts. The blue slide section is where I kind of just lay a foundation for the task analysis approach and just get you thinking about what it is and why it would work and how we can use it. And then the second part will be the actual steps that you can go through to create a task analysis. Okay, so let's take a look at the blue section here and lay a foundation for using this task analysis approach. So I had referenced task analysis used in other areas, and that special education teachers may have seen this. So let's look at an example here. This is my son Gabriel, and let's say he's a boy with autism, and let's say we have an objective of him dressing himself. And let's assume all the clothes are already laid out for him, and he's wearing pull-ups, and we want him to pick up the clothes and to put them on, and including socks and shoes. So let's list the steps for him to get dressed in the morning. So these may be some of the steps, starting from maybe he's going to put underwear over the pull-ups, all the way down to when he finally puts on his shoes. So we have this list of steps. And so by taking the objective and breaking it into these steps, we've conducted a task analysis. And so a task analysis is just a formal procedure for doing this, for breaking an objective or a desired skill or a targeted skill or a behavior into steps, sequential steps. And then notice I have on here that it can be used to guide assessment, and that's obviously a big deal, and especially in math, as challenging as math can be as for instruction. I'd like you to think about what we're doing in terms of directions. So what happens is we have a starting point and an ending point, and then we have the steps to get to that ending point. And that's what a task analysis does, is it comes up with these steps that are to follow, and a lot of the steps are in sequential order. What happens is the students may get lost at a certain step. Maybe that's the only step that causes them trouble. Well, in math, you can see how a student misses a single step and then they become totally lost. So the analogy really kind of works for a couple reasons. It could be the case that if they had done step 5 correctly, that they could have done step 6, 7. Oh, it's missing step 7. Never noticed that. It's missing step 6, 7, 6, 8, 9. He could have, the student could have completed steps 6, 8, 9, but they got lost at step 5. So maybe that's the only step that's causing trouble. And so what a task analysis does is it helps identify that one step and then just to drill down and to focus on that one step and get the student past that step. Another challenge to this is that these steps that we're looking at may appear so simple to us that it's kind of like looking at a color blindness test, where the student looks at this and they don't see a number, and I'm actually blue-green colorblind, so I don't see a number in here. Likely the rest of you look at it and you see the number immediately. That's what happens a lot of times in math, where we have a math step that seems easy, and it's easy for us then to think that the student gets it because it's easy, but they may not be able to see the number in the color blindness chart. They may not be able to understand that one step, even though it looks really easy to us. So the idea about a task analysis is it really helps us zero in on these steps and to think about them because the student could get lost with a wrong turn. So we start by assessing the student on all of the steps. We do a pre-test, and that's what you will be doing next week. After the pre-test, you could then drill down to either a set of substeps, a subset of steps, meaning a couple steps where they're having trouble. Let's say Gabriel's having trouble putting his shoes on, and maybe we need to go over all 3 steps for that. Or maybe it's just a single step that we need to focus on. Maybe it's just getting him to match his shoes to his feet. And then you would provide instruction to target those steps. So for this one, if Gabriel's having trouble matching his shoes and feet, maybe we just focus on some instruction on that, with the idea that any type of accommodations would be eventually faded. Same thing would happen in math. And so here's an actual example of what this might look like in math. So we had an objective here for a student to measure to the nearest fourths using a ruler. And what I did was I looked at the data, and we'll talk more about this later. And actually, this is actually a data sheet that I have made available to you, but it's not one that we'll use in this task analysis. It's one that we use later on. Later on in the assessment process when you're doing instruction. So I've alluded to this, but we're not going to delve into this. But this would be a data sheet that we could use to assess the student's ability as we're going through all the steps. And let's say as we did that, we noticed that the guy is having trouble identifying fourths. So what I've done is I created a handout for this kiddo, and the whole focus of this is simply to focus on fourths. And he is asked to take a highlighter and to highlight across how many guys have a hat in the first row. And so he would highlight the first 3 guys, and then that would lead us to 3/4. The next one, he's supposed to highlight the number of Jeeps out of all 4 cars, and he would highlight the first 2. And the focus here is just identifying fourths and helping the student to see fourths. And eventually he would do that in a ruler. And I actually talk about this later on in the video. But I just wanted you to get an idea of what happens. You identify some steps to target. You provide instruction. Well, we do that with in other areas, so we can do the same thing in math. And then you could even take that a step further and then start focusing on the ruler. So you can start with something where you really do a lot of scaffolding, and then do a little bit less scaffolding and move them towards that desired skill. Here's some other examples of how this whole task analysis approach plays out. So this is actual work of a student that I had in consumer math. What I'd like you to do is to break this down. And this is a closed-ended question, but I want you to actually think beyond this. Do you think the student is totally confused by coins at looking at this, or do you think maybe we can drill down and find that one turn where the student took a wrong turn? So hit pause and let's unpack this, and then we'll talk about it. Okay, so what you'll notice here is the student got close, 10, 20, 30, 40. So he got up to 40, it looks like, and then what else happened? Well, I'm thinking he did 50, 60, and then what do you think he did with the pennies? Maybe 65, 70. Try that again. 10, 20, 30, 40, 50, 60, 65, 70, or 10, 20, 30, 40, and then the pennies are dimes, 50, 60, and then he did the nickels, 65, 70. So what happens, it looks like, is it appears he counted the pennies as dimes. And so you could drill down then into the step of the student simply distinguishing between pennies and dimes when you're given a set of coins. And that would be the same as targeting one step and getting dressed and providing instruction on that one step. We could then zero in on that one step. That's the idea of a task analysis. On an aside, I actually looked at, when we did the consumer math course, all the steps involved in teaching a student to count out the total value for a given set of coins. And as you saw here, once you start mixing up coins, then all of a sudden the student can get confused. So I took that into account and came up with literally 5 pages of steps to follow in order to teach a student how to count out the total value, because as you add additional coins, then things can get confusing. So I'm going to have this available for you on the website, and then you can ask me follow-up questions, even if you're not teaching this particular objective or addressing this topic. Let me know, and I'm happy to share with you what I have. Here's one that's a little more algebra, a little more mathy. So the idea here is for the student to simplify this expression. For those of you that are less math oriented, this is an expression and not an equation because there's no equal sign over here. And by simplify, what we mean is combine like terms. So hit pause and maybe think about what would be the first step, and then we'll talk about it. Okay, the first step would be to identify what we mean, what the like terms are, the 2 in red and then the 2 in blue. Notice the signs in front, the minus in front of the 3x and the minus in front of the 5. That's another step that's actually separate. What happens is a lot of times people jump right into that and they do both. They say, when they think the first step is to identify 7.5x and minus 3x as like terms. But there's other steps mixed in there, and that's why students can have trouble in math and not get the help they need, is because we tend to overlook all these little steps and we jump right up to a higher level. We combine multiple steps together. So we want to just focus on what we mean by like terms. Then we want to talk about the signs, and then we want to talk about combining them together. And then finally, the kids need to know that they can't combine these last 2 numbers together because they're not like terms. Kids will do that. They'll combine like terms up here, and then they'll combine these things down here, and it really seems like a contradiction. It's because when you mix things up, kids get confused. And so here's, so let's look at this. Here's a situation that is very common in working with Algebra 1 students and probably middle school students. I want you to identify the mistake, but I'd like you to also identify the step that's causing the student trouble. So I'm sorry, you can hit pause and do this, and then we can talk about it. Well, they may be confused by equation versus expression, and that's actually not something that we identified here in the steps. And so what I want you to understand is there are things happening in the brain, these mental steps that need to be addressed, even though you don't actually see them writing it out. And actually in the journal article I ask you to look at, they actually address that, talking about the mental steps. So what happened here is the student thought it was an equation, and then that they could do something to both sides of the equation, the equal sign. The problem is there is no equal sign. So they need to understand that it's an expression and not an equation, and simplify means to combine like terms instead of trying to do something to both sides, which is a solving step, which is this over here. Okay, this is an actual situation that I had. I had to replicate it a little bit. And by the way, these are actual the images from a handout. This is from mathaids.com. Outstanding website to generate worksheets. And their money. They don't use clip art. They use actual, looks like real photos of the coins and bills. It's tremendous. Anyway, I'd like you to hit pause and try to figure out what the mistake is here. This is really intriguing. It took me about 5 minutes, and then it clicked. I was like, oh my, I see what he's doing now. I see where he got lost. So hit pause and think this over. Well, what stood out to me immediately is he got 6 on all 3 of these. And that would be from, I'm thinking from the 5 and the 1, the 5 and the 1. So I'm like, okay, so he knows he has 5 cents and 1 cent, but then what happened with these others? And then it occurred to me, he counted the last nickel as 5 cents, but the other nickels he counted as dimes. So 10, 20, 30, 40, 6. 10, 20, 30, 40, 50, or 46. Oh, so notice here, the 10, 20, 30, 46, 10, 20, 30, 46. So even when the nickel was changed to a dime, it was still 40. But then here he did it correctly because he counted this nickel with the penny and gave me 6 cents. So we could then zero in on counting nickels, all nickels as 5, and just focus on that one step. This is a photo from a Burger King, and I had stopped by waiting for my coffee. I looked over, and it struck me that Burger King was doing an outstanding job with task analysis. These are images of how to pour a soft cream ice cream cone, and they have beautiful pictures and steps and explanations. It's a task analysis. And it occurred to me that if Burger King can do such a great job with a task analysis, we educators should be able to do the same thing, especially for math. So let's see how we can actually do that. Let's get into the red pinkish section here and look at the actual steps. I've been talking about this in all the videos. These steps that you are to do in the assessment process, steps 1 through 6 are what we're covering in this course. Steps 1 through 5 are actually creating the task analysis. So I'm going to ask you to work through one, and we're going to do it in steps. And so I'll ask you to hit pause and try it. Again, this is sneaky, tricky, and most of you will have some trouble. And so try to do this one that we're going to work on together. Try to do it as you go through the video so that you can see how we do it. Kind of a we do before you do the you do. So instead of me doing an I do all by myself, I like for us to do a we do and then a you do. So step 1 is you have an objective. Well, you covered that last week. This is one, it doesn't look good, but I wanted to give you an actual IEP objective. This is one that I want to use for this example, for this we do. And that is you're going to compute the total you have to pay given a tax rate and the price of multiple items. And the idea is that this would be like a multi-step real-life problem. So step one is to make sure you have an objective, measurable, observable objective. And so we've already covered that, so I'm going to move on. Step two, the idea is for you to create an example problem for the objective so that you can drive the route on your own. I had a friend who explained that he was having a gathering at his house. He was trying to give everybody directions. He wanted to give everyone very clear directions. So what he did is he actually got in his car and drove the routes that the people would have to, his guests would have to follow to get to his house. And he recorded all the steps. And that way he actually saw firsthand what the guests would have to do. So the idea is for you to do the same thing, drive the route. So if you want students to do this objective, then you do this objective. So what I've done here is I've created a problem to be aligned with this objective. And then what I'd like you to do is to work through it. So you've created an example problem. And now what you're going to do is you're going to work it out, and that'll be step three. Notice I've already done this, and I did it by hand. I highly recommend you do it by hand because the students are going to work through it by hand. If you're busy typing, you're going to be worried about the formatting, and that's an extra layer to deal with. Just get it on paper, write it out, and then we'll transfer it to a formal document, and you'll see that later on. So what I'd like you to do now is to actually solve this problem. For this is what you're going to buy, and then calculate the total. And by the way, these are items that a student that I was helping, that he really likes. So I try to make it meaningful to him. So go ahead and hit pause, work it out, and then let's talk about it. Okay, this is what I came up with. And then you can do it on the calculator, but it's still good to look and show the work. And then I actually added here. So I actually did the multiplication on a calculator. Now what we want to do is we want to identify all the steps that are hidden in here. Some of them are obvious, and some of them are some mental steps that you have to think about. Similar to the combining like terms, when I said identifying in the brain what the actual like terms are, and that the sign should stay with the term. Those are things that are happening in the brain that you don't actually have to write those out. But we want to capture those because we need to assess whether those students are doing that, whether that's happening in the brain. So I gave you a template to use, and there's 2 pages. The first page is one where you write out the steps for this specific problem, and then there's a second one that you'll use afterwards. So there's 2 pages. We're looking at the first page. So what I want you to do is to go through and list all the steps, and then do it in pencil because you may be erasing, or you might want to rewrite it. You might want to print it out twice. And so go ahead and try that, and then we'll talk. Hit pause. And I really recommend that you try this because it is sneaky tricky. Okay. So one of the very first things in here that is easy to go over our heads and not even think about is that when the student's looking at this, they need to distinguish between 6% and the dollar amounts. They need to understand that this is a tax rate. It's a percent, not a monetary amount. So they need to identify the dollars that are the items that they're going to add. What'll happen is we'll jump right in and start adding and say the first step is to add. The mental step is something we have to assess first. So these are the actual steps. I typed it just for the sake of this presentation. I would say handwrite it in there first. Just get your ideas on paper. Notice here there's a conceptual step. The students need to understand that tax is what tax is. It helps to make this information meaningful for the students, as is the idea that you're going to actually pay the person this much money. It's one thing to calculate it, it's another thing to actually use it in an authentic setting. And they need to know, I'm going to actually hand this money over to somebody. So these are the steps that you could write in, and then following this is you're going to rewrite all of these steps again on the second page of the handout, but you want to generalize it because these are steps. So we're going to generalize, now we're going to generalize the steps that we had previously so that we can have a document that would be useful for any type of multi-step problem, not just Doritos and whatever we had earlier, AC/DC shirt. So on page 2, take out that template and try to write each of these in general terms. So instead of writing identify $2.50, 79 cents, and $18.99 as prices, your first general step would be distinguish between prices and the tax rate. That's one possible way of writing that. So you can type that one because that one now is, you're just getting your formal document created. If you want to handwrite it first, you can do that. So why don't you try to write the general steps and then hit pause and then check with what I have. And so these are the general steps, and this is an actual document now that you can use for any type of multi-step problem with the tax rate. And so what you can do is you can use this, print it out as many times as you need for however many students, use it as a pre-test and a post-test, and then you can record. And you can see on the handout how it's laid out with where you write in the problem and the date, etc. So let's try one more. Again, this is sneaky tricky. I keep saying that because it is surprisingly challenging. So try to do the same steps that we just went through for this objective. And I strongly recommend that you take a ruler and actually try to line it up with an object and measure it and keep track of all the little steps, including the mental steps, and get those written in the task analysis. And then check your work with what I have posted. And so you'll see that I have this information posted for you with the specific steps and then the general steps. So let's wrap this up. So the idea here is to take a math topic and to break it down into a list of steps, and you use that task analysis approach to do so. And then what you'll do then is you'll use that for your pre-test with your student next week or in the next couple weeks. And then this would also be one that you would use for a post-test, and you could also use it for progress monitoring. And this will help you then drill down to find those turns, those steps in the directions where a kid takes a left instead of a right, and you can narrow the focus and address that one piece there to try to help move kids along. So I will see you in the coaching sessions, and please let me know what questions you have.